Hi, this is a demo of Dynomate. Dynomate is a DynamoDB GUI desktop client. It's comparable to Dynobase and NoSQL Workbench. The core difference is that it fits in with your existing developer workflow, as I'll show in a minute. Dynomate works with your existing profiles in your AWS config file or your credentials in the credentials directory. So to get started using Dynomate, you would need to have at least one profile configured. To connect to a table, we have a table discovery feature that lets you add tables you'd like to query. So in this case, I click on Discover Tables, select a profile I'd like to use to connect to my table, and then it will attempt to authenticate me, and in this case I have an expired session, so I can click login to kickstart my SSO login, and I'll just click allow access in the browser while it continues to verify my credentials. Okay, so great. Now next I select a few regions I want to discover tables from. So select US West 2 and AP Southeast 2. I'll click load tables. So it does load tables in both regions and provides a summary. If something goes wrong or it can't access a region, you would see an error as well for each region. Then I can close this window. Great. So now that I've added the tables, I have two ways of viewing tables. First of all, the tables are in the sidebar. So this is the profile. The tables are grouped according to profile and then region. So you can see this here. So I can click on this to open a table. The other way I can open a table is to use the search bar up here, or the shortcut Command K, which opens this global search that lets me search for a table. So I'll just search for the email logger table. And you can see that here. Great. So as you can see, selecting a table opens it in a new tab. So it means we can go from tab to tab, table to table. We can view as many tables as possible and just switch between them. These can be multiple profiles, different accounts, different SSO sessions. It doesn't matter. Each tab has its own state and its own connection status. So I'll just close this 3 for now and focus on this 2. So in here, I have a table view, which has the information in tabular format, and a JSON view. I also have this scan mode, which I was just run, which is where we are right now. And then I have this query mode, which lets me run queries, simple queries. So these query interface is actually different depending on the schema of the table. So in this case, this table just has a primary key of string type, and we have that field here. For the email logger table, if we look in here, this has a primary key. Sorry, this has a partition key and a sort key. So we have a different UI here. If we were to have indexes, you would also have the option to select indexes here. So I'm just going to run a query. So for the user details table, I'm going to run user #1 for the PK, and that gets me this. So I have this JSON view. I have JSON view for scan as well. So I can search in here for something. Command F, settings, very easy. So JSON editor is very useful. I also have the option to add items. So I can add as many items as I want in here, and I can edit as well. I'm trying to make this video short, so I'll skip through that, but it's pretty straightforward to run the edits. You can click in here and change something, or change it in the sidebar here. The other thing on this view we have is this logger, which just shows information about each request to help with debugging. So you can see the raw information that was used for the request, and we have this for both scans and queries. In the title bar, we have information about the table being queried, table and profile. So you see the profile, the region, and the table name. We also have this connection status that shows whether or not you're connected. If you're connected, there's some information about this session and the token expiration. So in my case, this expires in about 56 minutes. If I'm not connected, I get a button here that I can click to kickstart SSO login. This view is very useful for simple operations, scan and query. So if I want to query a single item, I can run it. I can run this and run a query. So what we have here is basically what you'd find with other GUI clients like Dynobase and NoSQL Workbench. However, in practice, I find that I need to run multiple queries at the same time to get some information oftentimes, because the data I need is stored across several entities, either within the same table for a single table design, or across multiple tables in some cases. Some other times, I need to first find some data for one entity and then use some other attributes from that fetched entity to fetch that fetch row to query data for another entity. So as a result of this, I'd usually write a script to do this. So everything I need to do for DynamoDB in production, I'd either manually, run one query, take note, copy an attribute and use that in another query, or I write a script to do it. So to solve this problem, I have built this query request system. So queries allow you to perform one or more DynamoDB operations. We support query, update, put, and delete. So the queries are grouped into folders here. I'm just going to go into this. I'm going to go into SAM folder, actually, and I'll create a new request. So as you can see, it opens in a new tab like the others. And I'll add one operation to this request. So let's just run the same thing we had earlier. So we'll run a user profile query. I use the same thing. And then for the ARN, I will select user details table. So I can just select this table because we've already imported it. If I didn't have the ARN, I could type it in manually. And then for the PK, I'll go use a #1. I'll just save this for now and run execute. So I get the list of items in here. I get some more information about the requests. Great. So I'll rename this request. I'll call it demo user info. So if we go back to our table, we have user profile entity, user activity, we have user settings, and user order. All of these are saved with the user ID as a prefix. So if I wanted to get all of this information, let's just say I want to get the order and the activity for this user. So I could do that by adding to operations user order. Oops. Save this one and then add another operation and call this user activity. Okay, I'll save this as well, and then I'll run execute. So I have user profile, user order, and user activity. So this returns activity, this returns the other details, and this returns profile information. So great. So this helps me query multiple. This helps me run multiple queries, multiple operations in the same request. The data here could be saved in the same table. So in this case, I'm just using the same table, but this could be different tables across different accounts using different profiles. It doesn't matter. Just select the profile, the table, and execute the request, and it will run. So you can also use the result of one operation in the next operation. So for example, in my email logger table, I have my primary key as a partition key as Alice as email, the email field, right? And I have an email. If we go back here to see the user profile, you see that it returns an email. So let's say I want to get the logs for the email logs for a user. So for Alice. So I could just go here and I'll create operation just like before. I'll call this user profile again. Save this. Call this let's see, demo user emails. Let's just call it that. Okay, so if I execute this, I get this. So we have the email field. So what I want to do is I want to use the result of this field query to get I want to use the email content of this query to get the email logs for that user. So I can add an operation here and I'll call this user emails. Same as before. And then here, I can use the syntax. So based on the request name, user profile, so I can go user underscore profile dot items, because I'm using the items field in the JSON result. So the first item dot email. And I'll just save this. So if I execute this, moment of truth, nope, it did not work. What did I do wrong? Oh yes, I get this wrong all the time. So I'm using the wrong table, user details. It should be email logger. Okay. So if we run this again, now we get the email logs. So you can see that these are the email logs for aliceexample.com. So great. So this makes this really powerful because you can run, you can run multiple operations, and because you can run put item, update, delete, you can do very interesting things. Now, the next thing I want to talk about is variables. So Dynnomate also has a concept of variables, and there are variables at a couple of levels. So first is globally. So globally, we can set environment variables. So we can go in here to configure environment variables. So I'll just do a prod, and add a variable called user underscore ID, and the value will be user. Let's just go user #1, like we've done just now. So now what I can do is I can go here and go use that same syntax and go user underscore ID. So when this request runs, okay, I'll just run it first time so it doesn't work. And we can see. So I click execute. So it doesn't work because we can't find this. So if I select prod environment and I run this again, now it does work. So the user ID for prod has been used for the first request, and then the second request uses the result from the first request. So great. So that's at the global level. We also have variables at the request level. So here I'm going to add a user. I'll just say user. I'll just call it user ID as well. So this time I'll go user #2, all right? And then if I run this time, because we're using user #2, which is Bob, if I execute the requests, it does get bob at example.com. And because the second operation is based on the first one, we get Bob's email logs and no longer Alice. Request variables are useful when you have the same data across multiple operations for the same request. So here it's for this demo user info we looked at earlier. If I go underscore user ID, I'll just go, so here for this request, I'll go user underscore ID and user #2. And this can be a substring as well, right? So if I go like this or like this, it does work. So you can see it's changed to Bob. So this is where request variables come in. We also have collection variables. So it's possible for variables to be tied to the collection. And the thinking behind this is that collections can be shared with your team. So you could have multiple collections for different projects. And each collection can have its own set of environment variables. So because you have these variables, your queries can be really powerful. You can have the same query run against different environments. You can change the table based on the environment or the profile based on the environment. So it works really well. Lastly, I would like to mention that all of the data in Dynnomate runs locally. Your requests don't get sent to any cloud to be run or saved to any cloud. It is run and saved locally in your file system. The collection being saved to the file system means you can commit it to Git and you can use it in the future. You can collaborate with your team. That's the end of the demo. Please give it a go. There's no account creation required. and we have a free 7-day trial. Thank you very much.